Hello, and welcome to the Eye Care Alliance instructional training video for the Optopol PTS Perimeters. This step-by-step presentation will guide you through proper setup and clinical use of the Optopol.
The complete setup consists of three primary components: the PTS instrument, a monitor, and a mini computer attached to the backside of the monitor. All components draw power from the auxiliary ports on the underside of the table. The monitor can be adjusted to various positions depending on operator and patient needs. The up-down switch is located directly below the table's edge on the operator's side. The monitor has a touch-sensitive power button at the lower right corner. The PC is turned on by briefly pressing the power button. This will illuminate blue when turned on. On the back side of the instrument, near the power input, you will find the power switch. A blue band will illuminate when flipped on, and the startup process will begin. As with most automated perimeters, ensure the room lights are as dim as possible, with no light shining directly into the bowl. After logging into Windows, the PTS software is found on the desktop. Before opening, verify that the instrument displays a single red dot in the bowl, which confirms that it has fully started, without errors, and is ready to communicate with the software. Double-click the PTS icon on the desktop, or single-click the PTS icon on the taskbar to open. The software will present the Start menu upon opening. Use the active search bar to find existing patients. Typing the first few letters of the first or last name will automatically generate search results. The Today tab will display only patients tested on the current day, for quick reference. To search the entire patient list, ensure the All tab is selected. To add a new patient, use the Add Patient button. Blank fields will be generated to the right of the screen. Hover over any field for an explanation of the information required. Along with the patient's date of birth, the distance refraction of the patient's glasses or contacts is used to calculate the appropriate trial lens needed for accurate testing. Use the plus or minus toggles next to each field to set the patient's refractive offset. If utilized, the axis value will automatically round to the nearest value of 5. Select Save when finished to add the patient to the patient list. To edit or update patient information, ensure the patient is selected and click on any field to activate the patient information section. Adjust as needed and select Save when finished. There are two ways to approach testing a patient: the Examination tab and the newer Wizard interface. For ease of use and intuitive functionality, we will use the Wizard interface. After selecting the patient, select the Next button in the bottom right corner. Select a tile representing the test you wish to perform. Choose the first eye to be tested. In this case, we will select the right eye. After selecting the eye, the trial lens information will be displayed below. Use the calculator icon to generate the correct trial lenses to be used. If values remain 0, no trial lens is needed. If a trial lens is suggested, bring the trial lens holder to its upright position and place the trial lens into a groove. If both spherical and cylindrical lenses are needed, position the lenses in the order that the prescription is listed: sphere lens in the front, closest to the patient, and the cylindrical lens in the back. Now it's time to prepare the patient for testing. Place an eye patch over the opposite eye and confirm that the eye is fully occluded. Provide the response button to the patient and review proper handling. Instruct the patient to rest their chin on the opposite side of the eye being tested, and ensure that the patient's head is straight forward and not tilted to the right or left, and their forehead is in full contact with the forehead rest. Once the patient's head is positioned correctly, move the patient's pupil towards the center of the gaze-tracking oval by clicking or tapping on the center of the pupil. The up-down buttons may also be used for fine movement. If the pupil is too far to the right or left, Instruct the patient to slide their forehead in the opposite direction of the pupil adjustment needed, using their chin as a pivot. If a trial lens is being used, instruct the patient to place their mask below the nose to avoid fogging the lens. With the patient's head adequately positioned, move the trial lens holder towards the patient, stopping just before the holder makes contact with their face. Select the Next button to enter the testing section. Before beginning the test, let's go over some of the controls. The test is started by selecting the play button. The pause and stop button can be selected at any time during testing. The demonstration button can be used to provide the patient with a preview of what to expect during the test. This is especially useful for patients who are new to visual field testing or express confusion about the testing process. The head tracking button is used to allow the software to automatically adjust the patient's pupil alignment. When turned on, a green check mark appears, and the manual chin rest controls will be deactivated. The voice command button can be used to toggle vocal software announcements on and off. When on, a drop-down menu above provides an assortment of languages to select from. Gaze tracking toggle can be adjusted to 3 distinct star levels, ranging from 1 to 3. 1 star is the default level and will monitor the patient fixation by periodically testing the plotted blind spot. This replicates the fixation monitoring method utilized by the Humphrey Field Analyzer. The 2 and 3 star levels replicate the fixation monitoring approach of a hog-striped octopus by actively tracking the patient's pupil in real time and only presenting stimuli on the field if the software confirms that the pupil is fully visible and fixating on the central target. These options may increase testing times. The Advanced button reveals a hidden menu which, in addition to providing access to reliability test options, allows the operator to change the fixation target from default single point to a 4-point diamond pattern. To once again ensure that the patient is fully prepared for the test, provide a final overview of testing instructions. There are 4 primary instructions to convey. Fixate on the red dot at all times. Click the button when you see a flash of white light in your peripheral vision. The brightness will vary. Some flashes will be very bright while others may be very dim. Blink normally. Let the operator know if a pause is needed for any reason. If the patient expresses any uncertainty, a brief demonstration is recommended. At the beginning of the test, the patient's blind spot will be plotted. Blind spot plotting will allow the software to monitor fixation losses. It is very important that the patient gazes directly at the fixation target to ensure accurate plotting of the blind spot. 11 points are tested in total. A non-response, symbolized by a red X, indicates that a portion of the blind spot has been identified. A minimum of 1 red X is required to gauge fixation losses throughout testing. However, this amount will vary from one patient to another. If all 11 points generate a check mark, a notification will appear stating that the blind spot was not found. Before retesting the blind spot, review fixation instructions with the patient and verify that the eye patch is placed correctly over the opposite eye. Once the blind spot has been successfully plotted, field testing will begin. The number flashing larger at any given time represents the point on the field currently being tested. A partial green circle indicates that the point has been tested, but the displayed value is not finalized. An orange circle indicates that the point has been completed. A red circle indicates that a false negative check is being performed. While testing is underway, the test control window will display useful information. The testing status is presented as both percentage completed and estimated time remaining. Gaze errors will be generated only when gaze tracking is set to the 2 or 3 star level and will not be generated if gaze tracking is set to 1 star. HK represents blind spot errors. This value is equivalent to the term fixation losses, as seen on the Humphrey Field Analyzer. False positive errors will identify indiscriminate patient responses. False negative errors identify if a patient is either being timid in responding to stimuli presentation or not fully engaged in testing. The eye chart will display a running history of the patient's eye movement. From the baseline, small downward ticks represent eye blinks, and upward ticks represent loss of eye tracking or gaze deviation from fixation target. When the test is completed, a notification will be displayed to remove the trial lens from the holder if one was used. Select Continue to proceed to Test Preview. Five snapshots of the eye will be captured during testing to allow for documentation of patient alignment. Review these images and select the one that best represents the eye positioning throughout testing. A print button will send the test report to a printer. If configured, the Export Data button will send a digital report to a designated folder. When ready to test the opposite eye, select the Test button. The opposite eye will be pre-selected. Use the trial lens calculator and replace the lenses in the trial lens holder as needed. Perform patient and trial lens alignment, then select Next to perform the test. If you choose not to perform the test, a skip option will bring you back to the test preview page. When finished with testing, select the Save and Exit button to return to the Start menu.